So today we will begin our discussion on topic 4, solving exact and non-exact differential equation. At the end of this module, you should be able to identify ordinary differential equation as either exact or non-exact, or if you can solve it using homogeneous or even separable. So you now have four approaches to solving differential equation. You also apply test for exactness to determine if the differential equation is exact or non-exact, and to apply steps in solving differential equation to arrive at a general or particular solution. So let's go to slide number 1. This expression here is what you call a differential equation in the form of differential form. You have m as a function of x and y. You have n as a function of x and y. And to be able to find out if this is exact or non-exact is to apply test for exactness. What is test for exactness? You're going to find the partial derivative of m with respect to y holding x constant. And you also need to find the partial derivative of n with respect to x holding y constant. You recall partial differentiation in your calculus, in which every time you do a partial derivative and holding a certain a chosen variable constant, you will treat it as a constant, even though, as you can see, variable siya. X ba siya or Y ba siya? But you need to you have to have a different mindset such that, for example, in this case, you're setting X as a constant. You are not going to derive it. You treat it as the same as numerical coefficient. Treat it as a constant variable. Okay, so let's illustrate that in this example. We have 3x squared plus 4xy quantity dx plus 2x squared plus 2y quantity dy. So this is your m and this is your n. You notice we have two terms. We also have two terms here. So what we're going to do, first step, partially derive your m in terms of y. The first term of your m is 3x squared. But you need to derive this in terms of y. You don't have a y variable. In this case, this will be considered all constant. So the derivative of a constant is 0. And then the second term, 4x, will be treated as a constant. So you write that as is. And then derivative of y is 1. So for the second term, the partial derivative is 4x. For n, as a function of x and y, your expression is 2x squared plus 2y. The first term is 2x squared. Partial derivative with respect to x is 4x. But for the second term, that there's no x variable. So this is constant. The derivative of this in terms of x is 0. So as you can see, these two are similar. So it passes test for exactness. Second step is to get the integral of your m, this time in terms of dx, holding y constant. Okay, so what is the integral of 3x squared plus 4xy dx? So the technique is to write the variables or those expressions that will not be integrated outside of the integral sign. So the first term, we have 3x squared dx. The integral for this is 3x cubed over 3. So the 3 here will be canceled out with the 3 below. What's left is x cubed. The second term, we have 4xy dx. You will treat 4y as constant. So you only integrate x dx. And the integral of x dx is x squared over 2 times 4. So you will cancel out the 2. What's left is 2. Okay, 2x squared y. Because that is x squared over 2, which is the integral of x dx. So 2x squared over y. Plus, you always have to write g of y instead of writing c, because you're only integrating with respect to x. You need to find an expression of the function of y. When it will be integrated, you need to find this later on. So you will treat this as equation 1. Okay? Now, you go to the next expression, which is your n. And you have 2x squared plus 2y dy. That's your n. Integrate that holding x constant, because you are only integrating with respect to y. Therefore, what is the integral of 2x squared dy? So 2x squared will be treated as constant. So what's left is integral of dy. But what is the integral of dy? Y. That's why we have 2x squared y. Then plus, what's the integral of 2y dy? Constant yung 2. So y dy is y squared over 2. Cancel out the 2. What's left is y squared. And then you add plus h of x, because you're only integrating with respect to y. So you must have an expression that will give the function of this integrand when integrated in terms of x. So you now have two equations, and you also have two unknowns. So what you're going to do next is find expressions of y to equation 2. In which case you see a y squared, which is exclusively y. And then you find an expression which is exclusively x into equation 1. And you can see x cubed. This is exclusively x. Therefore, your g of y is actually equal to y squared, and your h of x is actually equal to x cubed. So your final answer can either be this, but then you have to express this as equal to y squared, or you can also obtain your answer here in equation 2, in which you have to express your h of x as equal to x cubed. So next slide will show that your final answer is x cubed plus 2x squared times y plus y squared equals c. And you can check this by getting the derivative of this using implicit differentiation. So the derivative of this function is equal to, what is the derivative of x cubed in terms of x? So the derivative of x cubed is 3x squared dx over dx. What is the derivative of 2x squared y? You apply product rule here, in which first get the derivative of this, and then as is, plus the derivative of the second as is naman to. So derivative of 2x squared is 4x times y plus as is, and then derivative of y is dy dx. And the derivative of the last term is 2y dy dx. So every time you derive, as you can remember sa implicit differentiation, every time you derive the y, you write dy dx. But every time you derive the x, there's no need to write the dx over dx, because it's just 1. Equate that to 0, because the derivative of constant is 0. And then arrange it. You need to group together those without a dy dx. It's this expression here. And then this third term and fourth term has a dy dx. So you factor out dy dx. And to be able to express in the same way as our this one, you multiply both sides by dx. So this will be similar to our original equation. See, it's similar. So this is how you check your answer.